Hi guys, hope you all doing good. Today I'm gonna discuss about nodal analysis. In nodal analysis, today we're gonna solve some circuits, not some, one at least. And KCL plus Ohm's law gives you nodal analysis. This is one of the techniques for solving any circuits. We are having three main principles. That is, first finding out the principal nodes, then marking the grounds, then applying the KCL to the whole circuit. And today let's take the circuit and solve this. Here we have one voltage source, one current source, a resistor, inductor, resistor again, and another resistor. And what is a node and what is a principal node? You guys getting that doubt. And this is a node connecting to our more elements. This is a voltage, this is a current source, this is a resistance. This can be a node, and here it is connecting three elements. This is principal node. Here this is called node. This is again called node. 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 This is principal node, which is connected by three elements. Okay. Let's mark this as V1 and this as V2. The voltage generated in the resistor because of the V1 is V1, positive and negative. How positive and negative? See, the current direction is in this manner. So this is plus, 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 plus. And this is a minus here. Here also the same manner is followed. Plus, 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 and minus, 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 minus. Okay. So, and capacitor, we have to analyze it in two different manners. So, let us solve the circuit first. Let us consider node 1. Then let's go to node 2. What is a node 1? Node 2 is bit big. Let's do node 1. I hope you guys bear with my activities over here. So, in the node 1, what we have? In node 1, we have a current source, the resistance, and the capacitor is considered. How it is considered, I'll tell you. Let's draw the diagram. So that you guys will be clear about this. The resistance over here, capacitance. Okay. Oops. So this is resistance R, and this is C. The voltage developed will be different. I'll tell you. Here this is, this is node 1 and this is node 2. Okay, this is negative. Voltage at this particular node is V1 and the voltage at this particular node is V2. Okay, now let's solve this by applying KCL. First, let us find the voltage in the capacitor. I want you guys to be clear about this concept because it is the most confusing. I used to be confused. This is V1, right? V1. This is V2 and this is V1 again, V2, and this is VC. Now apply KVL to this loop. Applying KVL. Now we are considering only capacitor. So applying KVL to this loop, what we get here? See, negative to positive. How to consider this as? Okay, negative, positive. We'll get negative to positive, positive. V1 positive to negative minus VC positive negative is equal plus minus positive to negative means, and again voltage drop is equals to 0, right? Now we'll get VC is equals to V2 minus VC equals to V2 minus of V1, and VC is equals to V1 minus V2. Oops, V2. Is it visible? Yes. V1 minus VC, applying KVL. Here there's a raise in potential, here there's drop in potential, positive to negative. Of course, this positive to negative, there is a drop in potential. Here there is also a drop in potential. So like this, the signs are understood. So by this way we are getting the voltage in the capacitor. Next comes, we can apply directly. What we can apply? We can apply directly KCL over here. Now applying KCL to this circuit, I mean for the node 1, what it is? I of t is equals to, this is I of t, right? I of t is equals to V1 by R1. This is V1, the voltage generated across the resistor due to this voltage, V1 by R1 plus C into d by dt of Vc. Now we know that Vc is equals to V1 minus V2. We solved it, right? So I of t is equals to V1 by R1 plus C into d by dt of V1 minus V2. And we can write it as I of t minus I of t plus V1 by R1 plus C into d by dt of V1 minus V2 is equals to 0. Can write it in this manner. Okay. So we solved node 1 and applying the voltage at node 2. I mean the voltage is already applied. Now let us consider node 2. What is node 2? Here we can see node 2. This is node 2 and the voltage will be V2. And there is an inductor, resistances, 2 resistances, 1 voltage source. So how are we going to solve this? Yes, this is very tricky. Here, current is flowing through the capacitor, inductor, resistance. This circuit. So let's draw it so that you guys will be comfortable. Capacitor, inductor, okay, positive, negative, V of t. This is R3, this is R2, and this is L. C. This is V1. Let's mark this in another color so that you guys will be comfortable. V1, V2. Okay, V1, V2. So consider that. Rule again. Here 3. V1, V2. So VC. Here it is positive. We are considering this manner. So this is positive, negative. So applying KVL, we get this is also positive, negative, right? Positive, negative. This is voltage drop. Voltage, sorry, not a voltage drop. Increase in potential. V1. Again, increase in potential. VC. Again, decrease in potential, positive to negative. Minus V2 equals to 0. So VC is equals to V2 minus V1. Got it? Here there is a ground, obviously. So how to solve this? Messy. Inductor. There is node, right? V2. Now let's draw the currents so that you guys will be comfortable again. I don't know why I'm using this word too much. This is IL. This is L, right? IL. And this is IC. And this is IR2. Let us consider this as IR2. So, I'll read this equation. We write it as IC plus IL plus IR2 is equals to 0 by KCL. Currents leaving a node is equals to 0. Otherwise, current entering into node is equals to current leaving the node. So, by KCL. Got it? Now, we know the capacitor value is determined in this way. So, that is IC C into dVc by dt plus 1 by L integral minus infinity to t. This is current equation, infinity to t. V2 of V2 dt plus V2 minus V1 of t, V of t by R2 plus R3, because these are in series, considered as series, V by R by using Ohm's law. Okay, V2 minus V1, V2 minus V1 by R1 plus, R2 plus R3. So, furthermore simplification, what we get is C into d by dt of Vc is V2 minus V1 plus 1 by L integral minus infinity to t V2 or V2 dt plus V2 minus V of t by R2 plus R3. We are done with our nodal analysis. By this way, we can find out many equations by using this nodal analysis, and this is the way many get confused. We should be perfect in knowing this. Currents in an inductor, currents in capacitor, so that it will be like, tough otherwise. So hope you guys enjoyed my lecture, and this is the circuit again. Bye, take care, good night. Oh, this is night. Bye.